Hi, this is EE533 Network Processor Design and Programming Lab for using NetFPGA. This is Team 3. The members of Team 3 are Akshaya, Rajakumar starting this video. So for starting of the video, we just did a basic synthesis and using for this lab, Fedora 14. And for this, we initially started by logging inference router files into making to our lab 4 to make a evaluate a similar set final bitstream arrays. So for in order to synthesize the process lab 3, which is IDS, intrusion detection system. So the way lab 4 so lab 3 project of IDS into our lab 4 using an NetFPGA. After for time we did synthesis for that. During synthesis, we faced few issues. So here in NetFPGA Verilog core utils CRC, we found that the small file version 3, which it should be. And similarly, we found another issue we found was related to this here. Small 5.4, we don't have something called as progressively full threshold. We should have that, which we had to edit. And apart from that, another issue we found was over in system files had very lower number of lines, which caused us and not able to fix that. And also we had to upload our Verilog files and XML and project.xml, and then few few software files like IDS, like for SR source files, which has all our Verilog codes. So yeah. So these are the NetFPGA and core IP code. After this, we had to do synthesis, and also I'll show you the include files also. After this field, I'll do synthesis like yeah. So on synthesis, as we have done it in file, from synthesis, as you can see, this is our final bitstream file, FPGA system, and next step after this is to connect to a VPN for or like be at university and try to use the university Wi-Fi, secure Wi-Fi. We are in university, so we are able to connect easily. So I'll open the NetFPGA right now. So as you can see, right now it has around 4 nodes and one main NetFPGA terminal. Hand it over to. I'll also show you maybe the IPs of all the nodes. These are the IP for all the nodes. This is actually communication between each other and also nodes and good communication with the NetFPGA. I'll hand it over to Shreyas, who will take care of the next sector.
Hi. So yeah. Yeah. So I'm gonna go over from part 5. So just a sec. So yeah, basically after I like for the NetFPGA based Linux kernel IP router, the ping that is one point which I would like to highlight, because like we noticed that some other stuff, but whenever we had to like ping and then do echoes, like sometimes it let that notified professor and the TAs about it, they kind of rebooted the entire queue, which we ran into a couple of times. But I just want to discuss the said on part 5. So basically after keeping the server, I have to keep try different combinations between the server and the client. And so for example, 0, 1, 2, and 3, and then fixing as 1 as the server, and then all the 3 so a total of 16 combinations. And as highlighted in the report, we know with all the different combinations, like for example, keeping the NetFPGA 1, node 2, node 3 as clients, and all the other combinations and etc. One common pattern that we did notice is like our 100 Mbps, there wasn't any packet loss, meaning like even in the receiving side match 10 or 100 Mbps, but when the bandwidth was 1 Gbps, in the range of about 75 to 90% packet loss, there was like a common repetitive pattern which we found out for like almost all the key inferences, and then some of the other. So that is happening for almost all cases, but apart from that. 10 to 100, there is a linear increase in throughput, but yeah, the moment it hit, and so apart, so yeah, deliverables which are asked under section 5, and then when after hardware as an IP router, after following all the respective commands and then doing RKD, I believe that stands for router kernel daemon, and that basically from what we organization of process. So like. It makes sure slash happening. So and there isn't like any fighting of resources KD is used for. And then when we give the kill all RKD, like the whole then what else is asked? Okay, that's fine. Yeah, so the answers to these following questions, seventh part, and who's talking? So now Siddarth again is going to show like a proper working demo. Okay, so now Siddarth is going to show like a proper working demo, I believe from part 5 onwards. Yeah.
So, and we're doing UDP transmission. We're able to only work with UDP and not with TCP in Fedora. I'm not sure why. Here I'm using just $N2, or else you can actually enter the IP, which is like 10.7 points, something. Easier for me, I guess. So yeah, we're able to like keep note send and receive packets from it. So as you can see, I've sent like around 893 packets, random packets, and this without any like bandwidth setting. If I set a bandwidth setting, which is like this, right. So yeah, so here also I'm able to send like basically like sticking to the bandwidth of 10 MB of bandwidth and like keep it 100. But I think here over here we'll be able to see a bottleneck kind of scenario. This is a like maximum saturation. If I increase it more to like around 1000 MB, is around close to like 1 G. Yeah, as you can see, we're not able to reach 100 amps are like our maximum saturation point, after which it starts bottleneck and we're getting lower and lower bandwidths. From yeah, now moving on to RKD conditions and implementation using reference NIC. So for that, so I'll just
now I'll demonstrate the network communication between the nodes using the reference NIC FPGA node. And after this, we're going to try ping and see if it's working. So I'll just pick up this bit stream. Now we'll try for the reference router.bit. So before doing this, we have to do the RKD command. As you can see, it is successful. Like the ping is working for reference router as well. So can you pass through to. So before demonstrating the like the ideas on the net FPGA, a pass-through ideas, so which is basically modifying for kind of thing. So in this, we have removed all of the other modules and then replaced. We just have a fall through small FIFO here, and then in the pass-through, we just have out equal to in the ideas.b, and we have generated a bit stream. So let me try and download this into the net FPGA. Download.
okay.
So now it has been downloaded. Now I'll process this. Start a new one. Now I'll try to ping any of the node. From here on, I'll hand over it to Siddarth.
So the final part of lab part 7 and the whole lab is to implement our actual IDS project in the NetFPGA. For that, we have to import the net file we generated from synthesis. That file is called as I'll just download that first into the NetFPGA. That file is actually called as nf2 underscore top and no, oh sorry. So this is the our final synthesis post synthesis block, and we're just downloading into the NetFPGA. And after that, you have to like upload IDS reg file into this. I'll show you what the IDS reg file does. This is the main like Perl file we got from the professor. This contains all the IDS registers required for the project, and also main plan importance of this register is like we're going to give an ASIC string for this as a package. So this actually will convert the ASIC into more of an FPGA system with two sequence of lines, which I will see soon, and called as net pattern high and pattern low. And this will basically just converts the ASIC string into an bit or like a hex, and from this we'll just check for matches with the data, and based on matches are there, then we'll obviously have our drop before like sending packages. So this will be marked with matches, which is like a counter, which will increment if there's like a drop by from dropping. Another thing of importance here is to check for the registers which are to connect to the FPGA. So we are using. So yeah, these are the main registers for FPGA we're connecting. So basically, for this project, we use these registers with the FPGA for IDS operations. So almost like an GPIO registers for this project. So after that, yeah, I'll just do a reset of I'll make it into an executable file, and then I'll just do a reset of this. Yeah. So this will actually empty our whole register files and make the pattern 0. And after that, I will like I'll set the pattern as what the basic pattern we got for our example here: A B C D E F G. So yeah, as you can see, the pattern just changes to the value of this value. So it's actually what should be predictable. After that, I'll start the RKDN, and I'll check whether it's pinging with other systems or not. So as you can see, it's pinging, successful. And then now I'll check for matches now with which should be now P0 because we are not like having any data. And then yeah, I'll take node 2 as my server, and I'll like open the file we have our files from. So keep this as my server, and I will check for any matches. Okay, and this is listening. So yeah, this is sending us to client, and this is receiving. So just like get an update in few minutes, few seconds. Yeah, like sending. This must for this it's a good client. We won't have any patterns in this client, so we'll just get a 0 value. And next we'll check for a bad client. So in this actually we loaded a file called uh, bad file, which contains a pattern. I'll show you the file also. Yeah, so this contains a pattern. So for this file we will have a clash. First counter will increase. So yeah, the file for this also is getting sent for us, and here also we get an update for that. So, so thank you very much. This is the end of the project. Thank you.